Welcome back. In this video we're going to go ahead and talk about indirect illumination. Now in the scanline renderer we have two advanced lighting features that allow us to create indirect illumination like the way that light works in real life. We have the LightTracer and we have radiosity. In this case we're going to go ahead and get started with the LightTracer. So let's open up an example scene here by hitting Control O, and that opens up the open file browser window, and the scene that we're looking for is called LightTracer_start. So let's open that up. Pretty simple scene setup. We have a ground here, a white sort of ground or surface table, or table surface if you want to see it that way. We also have some teapots here just strewn about. And let's do a quick render here. Let's just hit Shift Q to do a quick render, and this is what we've got. Not very interesting. There's no shadows. The lighting is being cast only by our default global light, the default light that's created whenever you create a new scene in 3ds Max for you. Okay, so let's go ahead and change this. Let's make things look more interesting. First I'm going to switch from production render mode here to iterative, and I'm going to close that window down. What I want to do is I want to create a light in this scene so that things start to look a lot better than they do now. So let's go over here to the create panel and switch over here to the light icon so we can create some lights. Click here where it says photometric and switch to standard lights. And now let's click on Omni to create an Omni light, and just click here in the middle of the scene. You don't have to be too precise about it, just drop it right in there. And then we're going to use the move tool. W on the keyboard is a shortcut for that, and let's move this light up like so. So it's sort of just hanging up there like a light bulb in a dark room. Now let's render again, and things look a little bit more interesting. The default light is now gone because that's what happens automatically when you create a light yourself. But things still don't look too realistic. There's no shadows, for example, so let's fix that. With the Omni light selected, let's click on the Modify panel, and let's go down here under the General Parameters rollout and turn on Shadows. And switch from Shadow Maps to Advanced Ray Trace Shadows because they look good and they render very fast. So now if we do another render, we'll notice we have shadows. So things are looking more realistic, but there's still something wrong with this. It still doesn't look too realistic, and I'll explain to you why that is. Right now we only have direct lighting. So what's direct lighting? Direct lighting is the process of light coming off of a light, in this case the Omni light here above our scene, and just going straight as light rays and hitting an object. That's direct lighting. The light just goes from the light and hits these teapots and this floor, which obviously is not the way that light works in real life. In real life, light would bounce around in this scene many times. Now we can't imitate that in CG because if we did it exactly the way a light works in real life, well, we wouldn't be able to calculate it. Simply, our computers just aren't powerful enough to calculate that. But we can do some little tricks. And one trick in the scanline renderer is using the LightTracer. And the LightTracer can imitate indirect illumination using its own little features and parameters, which we're going to look at in this video. So what we want to do is we want to make the dark areas behind these teapots look much more realistic. Right now they don't look realistic because they're so dark. In real life, light would bounce off of this light colored floor, and it would cause a nice subtle indirect ambient lighting on the backs and the shadowed areas of these teapots. So how can we do that? Well, we're going to have to open up the render setup window. So let's go over here to rendering, and let's click on render setup. Shortcut is F10 on the keyboard. And over here in the common tab we're not going to change anything. Let's go to the renderer tab and let's make a couple of changes here. The first change we're going to do is under anti-aliasing, we're going to uncheck anti-aliasing. Anti-aliasing is going to improve the quality of the render, but it's going to take longer to render. And since we're doing preview renders, we don't need anti-aliasing slowing us down. So we'll turn that off. We'll also check on Enable SSE, which is off by default. This stands for Streaming SIMD Extensions. If your processor supports SSE, enabling this option can give you a little boost in render times and performance. So I'm going to go ahead and turn it on. Then I'm going to switch over to the Advanced Lighting tab, and you notice by default it's set to No Lighting Plugin. By default, the scanline renderer doesn't have any type of advanced lighting set up, so we have to do it ourselves. Let's click right there and open up this drop down list, and we get two options, the LightTracer and radiosity. We'll talk about radiosity in another video. Right now we're going to focus on the LightTracer, so click on LightTracer. Now the parameters for the LightTracer open up. We have basically two parameter sets, the general settings parameter set up here, and then down here we have the adaptive undersampling parameter set. So let's focus on the general settings just for the moment. I'm going to move this over here to the left, and I'm going to take this rendered frame window and just move it right about there. Okay, now that we've activated light tracing, and I know it's active because up here there's a checkbox that says active and it's on. So if I do another render, you'll notice that we pretty much get the same thing. The lighting looks virtually the same. That's because it is. The reason that nothing happened is because by default there's an option in the LightTracer settings that has it basically turned off. And that is down here, this option called bounces. This is the amount of times that light can bounce around in the scene. The more times you have light bounce around in the scene, the longer the render is going to take, but the better it's going to look. So it's a sort of trade-off. By default it's set to 0, which is why we have this. If I go ahead and increase that to 1 and render again, you're going to notice that the render takes a lot longer now than before. But you'll also notice that when it finishes rendering, things are going to look a lot nicer. I skipped ahead a few seconds by pausing the video just so you wouldn't have to see that render process happen. I'm going to be doing that a lot in this tutorial, so no, I don't have some kind of supercomputer that creates instant renders. Alright, so we can see now in the dark areas of the teapots, it looks much more realistic. Diffuse light rays are basically bouncing off of the floor and affecting the dark sides of these teapots. This, of course, is imitating indirect illumination and makes the scene look much more natural and much more realistic. The trade-off, of course, is that it takes longer to render. So now let's start to look at these options and see how they work. One of the other settings that's directly and adversely affecting the way, or should I say, the time it takes to render this out, is the rays per sample option up here. This rays per sample option is set to 250 by default. This means that 250 rays are being shot out at each sample or pixel. To get it to render faster, just drop the number of rays. So I'm going to drop it down to 32. I like to use powers of 2. Been using computers for way too long. And if you use less rays, the render will be faster. So now if I render, I don't even have to pause the video. You can see that the render is much faster. But you're going to notice that you have some artifacting. The light solution is not exactly very accurate, and it doesn't look very good in high quality because we're using such a low number of rays per sample. So when you're doing preview and test renders, use a low number of rays. When you're ready to do your final production render that has to look really good, increase the number of rays. So we're going to use 32 rays from now on, just because we're doing test renders here and we don't want to get slowed down or take too long to do this. Okay? Alright, let's switch over here to 2 bounces, and now you notice if we do 2 bounces, the scene's going to be lit up a little bit more, and we're going to get some nice light bleeding wherever objects make contact with each other or are really close to each other. For example, I can see that the orange teapot is now bleeding some of its diffuse light reflection onto the white table, which looks pretty natural and looks pretty interesting. This is the power of the LightTracer and what it can do for your renders. Just take them up to that next level. Let's start to look at some of these parameters from the top and work our way down. The global multiplier is set to 1 by default. If I increase that to say 5 and I do another render, you'll notice now that the light bleeding effect, the light tracing effect, is now much brighter. It's blown out in this case, which obviously doesn't look too good. But just to go ahead and illustrate and exaggerate the example just so you can see what that parameter does. Okay, let's knock that back down to 1. Now let's take the object multiplier and let's put that to 5 as well. This is essentially going to do the same thing as the global multiplier, only on a per object basis as opposed to a global basis. So it's just another means to an end. As you can see, I've really blown out the effect in this case. It looks very grainy and very nasty. So let me put that back down to 1. Okay, we have some skylight parameters here, 2 of them. Right now we're not going to use them because we don't have any skylights in the scene. So if we change these parameters, you're not going to see a difference in the render. A little bit further in a moment, we'll create a skylight and then you get to see how that affects the scene. Color bleed is set to 1 by default. The color bleeding is going to determine the amount of color bleeding that objects can cast on each other when light tracing is in effect. However, if we change this setting, we're not going to see a difference right now. The reason is because our light bounces, edit that out of the video, starting again in 3, 2, 1. The color bleed parameter is going to determine how much color bleeding is cast between objects, how much of that light is spilling over from one object to another. Now by default it's set to 1, which is a pretty good setting. If I increase it, I'll have more color bleeding. Let me do a render here just so you see how it looks with a color bleeding set to 1. Okay, one important thing to know about the color bleeding parameter is that it will only work if your bounces is set to an amount of 2 or greater. So if you have bounces set to 0 or 1, the color bleed parameter is not going to make any changes. You have to have bounces set to 2 or higher. Okay, now to see the color bleeding a little bit better, we're going to have to do something here. Let me close this window here, and I'm going to switch the area to render from view mode to blow up mode. And you can see that the render square here is already set up around the orange teapot. That's where I want it to be. And maybe I'll even scale that down a little bit and place it right about there. And I'm going to hit render. So now we're going to blow up that area right there of the render. Okay, I skipped ahead, of course, because it was taking so long to render. Click on this button here to open up the render setup window. And over here, let's switch back to advanced lighting. Okay. So now you can see the amount of color bleeding that we have right now. Now, if the renders are taking too long to render, which in this case they are, there are a set of parameters down here under adaptive undersampling that are going to go ahead and speed up the renders here. So what I'm going to do is I'm going to switch some settings here. I have an initial sample spacing and a subdivide down to parameter. Right now by default the initial sample spacing is set to 16 by 16 pixels. And the subdivide down to is set to 1 by 1 pixels. So what do these numbers mean? I'll talk about this a little bit more once we work through these parameters on the general settings area, because I don't want to just jump ahead and start bouncing around back and forth to confuse you. So for the moment, just take my word for it. Let's switch the subdivide down to a lower number, like say 4 for example, and that should help us out here a little bit for our render times. And maybe I'll switch from 16 by 16 on the initial sample spacing to 8 by 8. Okay, and now I'm going to go ahead and hit render again. And now you notice the render is much faster than before. And I'll explain in a little while. I'll explain why that happened and how that works, and how you can use that to tweak your render times. Okay, so we can see the amount of color bleeding here. Let's go to the color bleed parameter and change that to say 10, which is a pretty high amount. And render again. And you notice that the difference is pretty subtle, but there is definitely a difference. We have more color bleeding now. The color bleeding is now spreading out a little bit more and is a little bit more even. The color bleed basically does just that. It changes the amount of color bleeding in the scene. I like to use a default setting of 1, however, unless you really are insistent upon changing that parameter. Okay? Alright, so down here we have a color filter and an extra ambient. Let's see what that does. Let's go over here and switch from blow up to view so we can render all of this again. And let's do render so we can see what's going on here. Okay, there we are. Let's take the color filter and change it to a blue. Just any blue will do. And let's hit render again. You'll notice that now the areas of color bleeding turned blue. Now wherever there's color bleeding, you're going to have this blue hue to the color bleeding areas. So that can just be a way of controlling the color bleeding in your scene if you really want to change the color. Of course, that's not physically accurate, so I would stay away from changing that color. Unless you're going for a specific type of look where you prefer to take that artistic freedom and just change the color of the color bleeding. The extra ambient parameter is turned off, which is why it's set to black. But if we go ahead and set it to say green and hit OK, watch what happens now when we hit a render. Now the color bleeding is really bright and is practically glowing, which actually creates a very interesting and cool effect if that's the look that you're going for. If not, go ahead and just set that to black so you get more realistic lighting. Okay. Then we have some other parameters here. We have a filter size. Now you notice this whole time that the light tracing solution is very grainy and very splotchy. We can actually affect and change that using the filter size. Now, before I do that, I want to explain to you very quickly the reason that this splotching is happening is because we're using a small number of rays per sample, only 32. To start to get rid of that effect, you have to use a lot of rays per sample, which of course is going to increase render times. So a little way to cheat that is to use the filter size. Right now the filter size is very small, it's set to 0.5. The smaller the filter size, the more grainy and splotchy this solution is going to look. So let's increase the filter size to a huge number like 10 for example, and render again. And now you notice that the filter did an excellent job of smoothing out that splotching effect and really increasing the quality of this render. Increasing the filter size will increase render time, but not by a lot. In fact, we just saw by that little test render, it really didn't affect the render time much, if at all. So the filter size is a great way of increasing the quality without sacrificing render time too much. But of course, the light solution is not going to be very accurate. So now let's look at some of these other settings, like ray bias, for example. The only thing that ray bias is going to do, it's going to change the profile and the shape of the light bleeding. So let's have a look at that. Let's switch area to render from view to blow up again. And I'm going to go ahead and do a render. Now we're going to see this render done with a pretty high filter size, so things look a little bit nicer. Although we still have some splotching when we look at this from up close. That's because you can only cheat so much by keeping this at only 32 rays. It should really be much higher than that for a production render, but not for a test. This is fine. Here's a ray bias of 0.03. Let's increase that ray bias to something really high, like 10 for example. And let's render again. You can already start to see that the increasing the ray bias parameter changed and altered the profile of the light bleeding. Now the light bleeding is kept to a smaller area, completely changed its shape and the way that that light bleeding reflects in the scene. So if you're after changing the profile of the light bleeding, the ray bias is going to help you do that. I find it best, however, to use the default setting of 0.03 as that looks very natural and very predictable. Down here we have a cone angle setting. The light rays coming from the LightTracer are limited to this cone angle, to the area that this cone angle covers. By default, set to 88 degrees. The lowest setting you can drop this to is 33 degrees. So let's go ahead and do that. Let's drop it to 33 degrees and let's do a render. And you notice that it comes out a little bit darker. This is because now the rays, the LightTracer rays, are being concentrated in a smaller area. They're not spreading out too much. They're very concentrated and they're very tight in the area they can cover. That's because we lowered the cone angle. If we increase the cone angle to the maximum, which is 90 degrees, and we do a render, now you'll notice that the scene is more brightly lit. That's because the rays are now being spread out more, a lot. Now you can see that the rays are not concentrated to a small area right here really close to the floor in the teapot. Now the rays are spread out a lot more, so much so that it looks like the rays are even spread out past where my image is rendering here. I find that the default setting of 88 degrees works just fine and looks pretty natural. Now volumes. The volumes parameter is going to tell the LightTracer whether to take volume effects into account. So what am I talking about? Well, let's switch from area to render from blow up to view, and let's do a render here so we can see the entire scene here. Okay, so we're back to square one. What I'm going to do is I'm going to go down here, make sure that the Omni light is selected, and in the modified panel go down under the atmospheres and effects rollout, click on the add button, and now you get two options, a lens effect and a volume light. We want to go ahead and add a volume light, so either double click volume light or select it and then hit OK. And now you see volume light here in the list of effects for this light. Select the volume light in the list to highlight it and click on setup. And in setup, that'll open up the environment and effects window. Shortcut for that is 8 on the keyboard. You notice volume light is highlighted in yellow. And down here we have volume light parameters. The only parameter we're going to change here is the density. Let's change the density from 5, which is too much, to 1, so it's more manageable. Close that window. And now let's go over here and turn off the volume checkbox so we render this without light tracing affecting the volume. What the volume basically is, it's a sort of fog effect that goes over the light to create this sort of a foggy effect, almost like when you have a flashlight in a dusty old barn or a room or something and you can see small particles of dust in the air that cause this foggy effect. So here the LightTracer is not taking the volume effect into account, which makes the render look like this. Let me click on the gingerbread characters here to clone that window. I'm going to drop it down here so we have something to compare to, a before and after, so to speak. Now I'm going to turn on volumes by checking it on, and I'm going to hit render again. And you're going to notice a huge difference here. The main difference here is that the lighting is much brighter and looks more natural. I know it looks washed out, that's because of the volume effect. But if you notice, these areas that are dark look much more realistic than before. That's because the LightTracer is now calculating light including the volume. It's now including the volumes into its light calculations. So now you can see here's the before down here. Very unnatural. Doesn't look too realistic. Looks kind of like someone put some kind of semi-translucent filter over a camera lens. And here on the top, it looks much more realistic. It really looks like there's volume and there's dust and kind of like the smoky effect in the scene. So let me close this cloned window, and over here in the light settings I'm going to choose the volume light and hit delete to get rid of that, and that'll knock us back to square one, basically where we were before we added the volume effect. Now let's quickly go over adaptive undersampling. Adaptive undersampling is the alternative to grid spacing. If we turn off adaptive undersampling, we're going to get rays. These LightTracer rays are going to be spread out evenly throughout our scene. The good thing about that is that it makes the LightTracer very predictable, and it evens out the lighting very nicely. The bad side to that is that it takes too long to render. So, for example, let me go ahead and hit render, and it's not taking too long because we're using 32 rays. But it's spreading out the light rays pretty evenly across the scene, and you could see that it is actually taking a bit longer than how we were rendering before, and that's because right now we're using grid spacing. If we turn on adaptive undersampling, now what happens is that the renderer is going to go ahead and intelligently place rays where it needs them most. So in an area back over here where really we don't need a lot of rays, the renderer is going to go, okay, we don't need to use so many rays there. Let's focus those rays on detailed areas like these teapots over here and where the teapots make contact with the white floor. That saves rendering time, and it also focuses the light rays, the rays per sample here, in areas that it needs it more. That's the beauty of adaptive undersampling. Okay? So we have an initial sample spacing and a subdivide down to. So what are these settings and what do they do? To understand what they do, we have to be able to see what's happening under the hood, so to speak, of the rendering engine. So over here we have an option called Show Samples. Let's check that on. And now let's go ahead and do a render. Now you notice these red dots all over our scene. The red dots represent the pixels where the rays are actually hitting and being calculated. So we're actually getting a look inside the renderer, so to speak, here. This can help us to diagnose what's going on with the LightTracer and help us to fine-tune and tweak our LightTracer solution to something that works well and renders relatively quickly. Okay? So the initial sample spacing is going to spread out these red dots to a maximum of 8 by 8 pixels. The subdivide down to basically tells the LightTracer if you need to put more detail in a high detail area, go ahead and subdivide that 8 by 8 pixels down to 4 by 4. And in the drop down box we can choose a maximum of 32 and a minimum of 1. The advantage of using a large number is that the renderer renders much faster. The disadvantage is that the quality is reduced dramatically. So it's a sort of give or take. If you want high quality, you have to use a smaller number, but you're going to sacrifice render time. If you want speed, you have to use a larger number, but you're going to sacrifice quality. So just keep that in mind where you're going to go ahead and use adaptive undersampling. Now the initial sample spacing should be set to something fairly large. Now this is pretty much scene dependent. Some scenes you can get away with using something as large as 32 by 32 and render faster. In other scenes that may not look good, you may have to drop it down to 8 by 8, maybe even 4 by 4. I don't recommend you put the initial sample spacing to anything lower than 4 by 4, however, because your render times are going to shoot through the roof and your renders are going to take a really long time to process. So in this case, let's go ahead and use an initial sample spacing of 4 by 4 and a subdivide down to of 2 by 2. Actually, let me change the initial sample spacing to something huge. That way you can really see the effect. I'll place it at 32 by 32 and I'll hit render. Now you notice that these areas like back here on the back of the floor here, where the renderer determines that we don't need too many of these rays, you can see that there's huge grid space and there's huge areas where there's no red dots at all. Then in areas where there's high details, like these teapots for example, you notice that they're covered, they're just smothered in red dots. This means that the renderer went ahead and added more rays to these areas. And you'll also notice that when we do that, it renders much faster than when we had adaptive sampling turned off. When we turned off adaptive undersampling, that automatically activated grid spacing, and grid spacing took a lot longer to render than this does here. So adaptive undersampling is extremely useful and can cut down your render times pretty dramatically, so go ahead and use it to your advantage. In this case, this looks pretty decent, but of course I can't really tell because my show samples is turned on, so let me turn that off and render again. Okay, so that's what we're getting, and the reason this looks pretty decent is because my filter size is set so high. So let me lower the filter size back down to the default, which was 0.5. Let me render again. And now I get some artifacting. Things just don't look too great. Okay, now to make stuff look better, let's go ahead and reduce the initial sample spacing to something like, say, 8 by 8, and the subdivide down to, we'll set it to 2 by 2, and we can increase the rays per sample. But one other thing that I want to show you here is the subdivision contrast. So let me go ahead and back and turn on the show samples here, and let me do a quick render here. The subdivision contrast is a threshold. It's basically a switch that tells the renderer when to subdivide this more or less. So if I set this contrast to something really high, like 10 for example, the renderer is not going to subdivide a lot. As you can see, there's less subdivision going on. Remember these areas that had more red dots right here? They have much less red dots now. This is because their subdivision contrast is so high. This is going to cause renders to go faster. However, it's going to reduce the quality of the render. If we knock it down to something really low, like 0.5 for example, which is very low contrast, now you notice that we have higher concentrations of red dots all over the place, and the render takes a little bit longer to render. Your quality is going to increase though, because now you have a much more accurate lighting solution with the ray tracer. I suggest sticking with 5, the default, which is actually pretty good. It's a pretty good balance of putting detail where it's needed and just putting a small amount of points or rays out here where it's not needed. So you can play around with that contrast till you get something that's well balanced, looks good, and renders relatively fast. Let me turn off show samples. Now what we want to do is we want to increase the rays per sample. Now once we do that, however, the render is going to take a lot longer. So if we increase that, you'll see that the renderer takes a little bit longer, but we start to get rid of some of that artifacting, and it's a good idea to increase the size of the filter. If you want to cancel the render, just hit the escape key on the keyboard to cancel the render. Okay, next thing I'm going to do is I'm going to quickly create a skylight just so you can see the effect of that, and we'll be done with this. So let me close that, and let me close this. And now I'm going to take this this Omni light and hit delete on the keyboard to get rid of it. So now we're back to square one. What I want to do is I want to go back to the create panel, and under lights, next to Omni, you'll see this option for skylight. Let's go ahead and create a skylight, and let's just place it here. Now the skylight's going to imitate lighting coming from a sort of ambient atmosphere wrapped around your entire scene. So it doesn't matter if I move the skylight here or if it's down there. It's not going to make a difference. The skylight's still going to affect the scene the same exact way. So let's go over here to the modify panel, and all these skylight parameters are perfectly fine. What I want to do now is I'm going to go over here and open up the render setup window. Move that over here. Switch over to advanced lighting, and I'll do a quick render. And this is what we have. The skylight works great with the LightTracer. Those two are really meant to work in tandem together. The skylight's going to go ahead and create some beautiful, nice, soft ambient lighting, which is perfect for doing outdoor effects or outdoor lighting. You can see we have these nice shadowed areas down here, which looks very realistic and very, very visually pleasing to the eye. Okay. In this case, we probably don't need to use 2 bounces. We could probably get away with 1 just to render faster. And if we render that again, it still looks pretty good because of the skylight. Of course, it's a little bit darker now. If you don't like it looking that dark, you may want to go ahead and increase the bounces back up to 2. Now, to get this to render out really good, because we do have some splotching going on here, we may want to increase that filter size. So I'm going to hit escape to cancel the render, and I'm going to increase the filter size to say 5, which is a bit higher than before, not too high, and that should go ahead and smooth out some of this down here. Okay, and it did. Problem is, now the shadows don't look as good. They look fake. They look like they were composited in using an image editing program like, say, Photoshop. So I want to reduce that filter size to say 1. Render that again and see what we've got. Okay, that looks much better, much more realistic. But I still have that splotching going on. So to get rid of that, I'm going to increase the number of rays per sample. So I'll increase that to 256. Again, I like to use numbers of a power of 2. And I'll hit render again. This is going to take longer to render, so I'll just skip ahead. And this is what I have. Essentially, by increasing the rays per sample to 256, I have so many rays here that it's enough for this scene, and my splotching pretty much went away. yet I still have those nice contact shadows and that ambient lighting going on here. So it looks great. So you can see how great the LightTracer works when you combine it with a skylight. Now that we have a skylight, we can affect these parameters here. If I uncheck skylights and I render again, now the skylight is not going to be taken into account when we perform the light tracing or the final render. But of course, since the skylight's the only light in our scene, once we turn it off, everything just renders pitch black. So I hit escape to cancel the render and I'll turn the skylight parameter back on. This multiplier over here just increases the amount of lighting that's being created by the skylight. So if I double it to 2.0, the skylight's going to have a much stronger effect in our scene, essentially brightening up everything in our scene, as you can see. Of course, that's a very high number. I just doubled the amount of influence that the skylight has in the scene by increasing it to 2.0. So now everything is super bright. So the default setting of 1 is actually good enough. If you want to increase that, maybe increase it by small increments like 1.1 or 1.2, and you'll probably get a much better result. Okay, so that's going to cover it for light tracing and how to use the LightTracer, how to activate it, and how to use these different parameters to go ahead and change its effects and tweak it and make it look the way that you want it to look. So that's going to do it for this video. I'll see you in the next one. We'll actually look at an example of how to use the LightTracer in an actual scene and get that looking good. So I'll see you then.